Now we're at Physical Chemistry, Chapter 9, Section 1. We're going to be talking about solutions. A solution is a homogeneous mixture of two or more substances. Now first let's talk about solution composition. Now 1 asterisk means that a quantity is temperature dependent. 2 asterisks mean that the quantity is not temperature dependent, it's temperature independent. Okay, so for example, mole fractions, there's 2 stars. So mole fraction, that's going to be temperature independent. Mole fraction is chi subscript I. It's defined as the number of moles of substance I divided by the total number of moles. Like I said, this is not really an X, it's supposed to be a chi, but I can't really tell by the font, I'm just writing it with hand. Okay, the second type of solution is, excuse me, molar concentration. Notice there's just 1 asterisk, so this, excuse me, will be temperature dependent. So we got, that's C sub I, that's defined as the number of moles of I divided by the volume. The volume will change with temperature, that's why this is temperature dependent. And we also write this as capital M for molarity. So like I said, capital M is molarity. V is the volume of the solution, usually in liters of course. And then N subscript I, that's the number of moles of the solute. Okay, there's also mass concentration, 1 asterisk, so this is also temperature dependent. So basically this is rho subscript I, and that's defined as the mass of substance I divided by the volume. Again, volume will change with temperature, therefore this is temperature dependent. So like I said, M subscript I is the mass of substance I present in the solution. So that'll be measured in grams or kilograms, obviously. And then, of course, V is the volume. That'll be measured in liters or meters cubed or whatever. And we can do this if we know the molecular weight of the is not known, or the number of moles of the substance is unknown. Like if you have a polymer, you have different lengths of polymers, you might not know exactly how big your polymers are, so you don't know the number of moles you have. So you have to settle for using mass instead. Okay, another way to measure concentration is the molality. Molality, 2 stars, so remember that's temperature independent. So the molality, not to be confused with mass obviously, the molality of substance B is the number of moles of substance B divided by the weight of A. A is the solvent. Or put another way, it's the number of moles of substance B divided by the number of moles of substance A times the molar mass, or molecular weight of substance A. So remember, A is the solvent, B is the solute, just like above we had I for the solute. And then W subscript A is the weight of A in kilograms. And then M subscript A, that's the molar mass of A, or molecular weight. I'm going to use those interchangeably, but they're not really the same. Okay, and then of course another is weight percent. There's 2 stars, so this is temperature independent. So weight percent is just the weight of substance B divided by the total weight of the solution times 100%, of course, if you want it in percent. This is a common way of doing it for stock chemicals. So again, W total is the total weight of the solution. WB and W total have to be in the same units, obviously, grams for grams, kilograms for kilograms, whatever. So just this part right here, this WB divided by W total, the weight of substance B divided by the weight total, that's called the weight fraction. Now mole fraction and molality, you'll notice then, were the ones that are temperature and pressure dependent. Molar concentration is temperature dependent.